So, good afternoon, everyone. Welcome to the third week of this Principle of Construction Management course. I am your TA, Prana Mahajan. So, let me share my screen first. Everyone, please mute yourself. Yeah. So, let's get started. So, this is the third week of the Principle of Construction Management course. So, my name is Prana Mahajan. I am a PMRF scholar in Department of Civil Engineering from IIT Madras. So in this session, what we are expected to do? So in this session, we will try to summarize what we have covered in the third week of the principle of construction management, for which all the lectures are provided to you by NPTEL. And regarding the problems and doubts that whatever you incurred during this current week, you can make a note of that, and we can try to incorporate and try to solve them in this current session. So what we have covered in this session is that if you recall from the videos that what we have covered. So in this week, we have started with the construction of the RA bills. So how you made the RA bills? You made the description of the different quantities that are involved in the actual construction, not the estimated amount or the estimated quantity that is present in the bill of quantities, but the rate should be as per the rate which is awarded to the contractor as per the contract agreement. So the actual quantities that were involved during the construction work were taken into account in RA bills. And when you multiply it with the corresponding unit rate, you will get to know the total estimated amount of the quantity of the work or the description of the work that is required to be completed for a particular quantity that is involved in that project. So this quantity can vary from a percent from project to project. However, we in the initial stage try to estimate the quantities as close or as accurate as possible, so that no deviation in the total amount of work should happen. Another thing that you have noticed in the current week is that when two persons are quoting for the same work, so we allot the work to that person to whom the lowest bid was provided. That means the person who quote the lowest value, to whom only the award of work is to be done. But sometimes what happens is that that is a once in a while probability that both the contractors will quote the same total amount of the work will be same. However, what can happen that the rate for different items will be different for both the contractors, but when you accumulate both of them, then the total amount that is expecting for the project is coming out to be same. So what will happen in that case? So in that case, what happens? Suppose in what happens that suppose in contractor A, he has made a higher amount in concreting work, but lower amount in excavation work. However, contractor B, what he has done, he quoted the amount which is higher in the excavation, but lower in the concreting work. So what contractor B is trying to do? So contractor B is trying to gain as much money as possible in the initial stages of the work. So then what will happen? So this amount will accumulate over the time, and that is what we call it as a time value of money. So with change in time, when the project length is very long, time value of money is very important to us, because due to the increasing rates, changing the value of the money that we are spending day by day is changing, or we can say it is increasing. Suppose what you are purchasing at rupees 20 in 1995, now its value is around 150 in 2024. So that amount should be taken into consideration when quoting for a particular project or construction work. So that is what we call as the time value of money. So this is what we have covered in this current week, the economics of the construction of the project, in which we try to see that how the different factors that are affecting the total amount is calculated. So what is time value of money? So time value of the money changes with the time. So it represents the interest and the earning power of the money that could be looked upon as the premium paid to compensate the owner for the loss of use of the loan money. That means, suppose a person has taken a loan for the money. So if you have to compensate for that, so certain amount of interest should be paid. So that interest is called as a premium. So that will incur the loss that is happened to the contractor during its construction period. So thus there exists a permanent present value as well as the future value of the investment. So suppose you have done some investments, like you can say in mutual funds. If you talk about mutual funds, what happens in mutual funds? You say that you want a future value of around 20 to 50 lakh rupees, or you can say suppose 50 lakh rupees you expect uh, to income to have at around 20 years from this 2024. So that means by 2044 you must be having 50 lakhs in your account. So then how much amount of SIP is required to be done by you, so that this amount should reach a particular value, that is 50 lakh, within a period of time period. So taking an average of the rate of interest, suppose we can say 12% of rate of interest if you gain from the mutual fund compound yearly, which is compounded each and every year, then how much amount of SIP is required to be done. So that tells you the annuity. So, so this is what is the difference we are uh, understanding with the present value. So present value, suppose the 50 lakh you are expected to gain in the future. So for that, the current value is around 15 lakh, because at each year the uh, amount that is required is less. So that 50 lakh that is there with you in the future, that is in 2024, that may be equal to 15 lakh in 2024. So that, so your 15 lakh represent the present value of the money, and your 50 lakh represents the future value of the money. So for that, what do? We make cash flow diagram. So cash flow diagram is generally a representation of the inflow and the outflow of the funds, those that are either received or that are during the spent during the total project life of the uh, total project life of the construction period. Okay, so this is the journal typical cash flow diagram, wherein you can see, suppose, let's take an example of an construction equipment, wherein when you have procured an equipment, you have spent an amount of rupees 10 lakh, and for every year you are spending the maintenance amount, like 2 lakh, 50,000, 3 lakh, 50,000, 1 lakh, 1 lakh 50,000, and 4 lakh. So by this, certain amount is outflowed from your pocket and certain amount comes to your pocket, because this is the amount you have spent for the purchase of this equipment. Whereas this is the amount you regained by utilizing the machine for different years, so that you can earn from from that machine to what you have uh, put certain amount during its purchase. So the amount which goes out from your pocket and which comes into your pocket represents the cash flow diagram. So what how you determine this cash flow? So that cash flow could be determined as a single payment, wherein you calculate the compound amount factor and present worth factor. When you talk about equal payment, that is annuity. In that also, compound amount factor, present worth factor, a sinking fund factor, and capital recovery factor should be taken into account during the estimation of the future value of that particular project. Okay. So in this current week, you have seen multiple examples regarding how you calculate the future value of a money when you have the present value of amount X. Okay, so for that, we have different factors available with us, which will help us to manage our resources. So, to manage the cash flow with us, we need to take into account these factors, so that we should come to know that whether the project we are undertaking into consideration for our future expenses, whether it is feasible for us or not. Because a 10,000 rupees today is not your 10,000 rupees in 2044. So your 10,000 rupees today will be 60 to 70,000 rupees in the future. So taking into account the increase in the inflation as well as the increase in the rates of the commodities that is happening in the future, so whether the project when it comes into completion, whether it is giving you sufficient funds available in your pocket or not. So that what tells you the different factors that are involved during the calculation of the time estimation of the money. So see, we have different factors. So one by one, we will see each factor, and then see then how we can determine the present value, future value, or the annuity amounts. So let's get started. So first factor that we have taken into consideration is single payment compound amount factor. So that means you are supposed to calculate the future value of the money, given you have the principal value and the number of years. So suppose you have this value x. So then what will be the value of this x in future? That is required to be calculated, given the yearly interest rate is I. So how you will calculate? So as we can know from the compound interest, we will be having P is equal to 1 plus R to the power of n. Okay. So from this, if you take the principal amount to be unity, if you divide it by unity, what you will get? So this is the factor 1 plus R to the power of n. Okay. So this is what tells you. So in this, in compound interest, this is amount. So amount is P into R to the power of n. When you divide it by your principal amount, it will give you some factor, that is 1 plus R to the power of n. That is what is told you, like 1 plus I to the power of n. That means when you are required to calculate the future value from the current value, given the rate of interest to be I, then you apply single payment compound amount factor. Now we will do the reverse. Now we will calculate the principal amount from the future amount. Suppose in future, in 2024, 2044, we feel that we should have a 50 lakh in our pocket. So to have the 50 lakh in our pocket, what principal amount should be there in today? So how we will calculate? So we will reverse this factor. So your single payment present worth factor will be inverse of. So your single payment present worth factor will be inverse of single payment compound amount factor. Okay. So this is the relation when you are directly estimating the compound amount in future, or vice versa. You are calculating the present value of the money, taking into consideration the future value. So when only future value and present value are into account, then you can use these two factors. That is single payment compound amount factor and the single payment present worth factor. Okay, so let's move further. Another factors that are available is for the annuity. So when you are not providing the principal or the present amount, but you are providing the money in certain intervals like EMIs, like EMI, what you will do, or mutual fund SIP is what you will do. You will give certain amount of money at particular interval of the time. So when you give particular interval this money at a particular interval of time, then what will be the amount that will be accumulated in future? So if you are interested to calculate the future amount, when you are giving the annuity amount, say 20,000, so over a period in which you are expected to earn the interest at the rate of I percent annually, then what will be your future amount? Then how we will estimate is by using equal payment compound amount factor. So when in the question it is mentioned of compound amount factor, then you are expected to calculate the future value. That means your future value is unknown. Whereas when it is mentioned the present worth factor, that means you are expected to calculate the present value of the money. Okay. So in this case, how we will calculate? So we will calculate by using this formula, that is 1 plus I to the power of n minus 1. So by this, you will get the compound amount factor. When you divide it by the rate of interest, you will get the equal payment compound amount factor. Okay. Next is inverse of this. When you are expected to calculate how much amount you are provided as an EMI or as a SIP at regular intervals, so that you will reach the value of 50 lakh in future. So then it will be reverse of that. That means your equal payment sinking fund deposit factor is inverse of equal payment compound amount factor. Okay. So equal payment sinking fund deposit factor is the inverse of what we have seen in the equal payment compound amount factor. Next is when you are expected to determine the present value of the money, given you are providing the annuities at regular intervals. So then what will be the case? So in this case, your equal payment present worth factor. So remind this word present worth. So when you are expecting a present worth, that means you are expected to calculate the present value of the money. Okay. Then in this case, it is 1 plus I to the power of n minus 1 divided by I into 1 plus I to the power of n. Okay. Another thing is reverse of this. When you are expected to calculate equal payment capital recovery factor, so that is P is given to you. You are expected to calculate the value of A. Then how you will calculate? Same earlier, you will invert the equal payment principal worth factor. So that means equal payment capital recovery factor is inverse of equal payment present worth factor. Okay, so these are the different factors that are available with you so as to calculate the amounts. So that means you have total 6 factors. So when you don't have annuity available with you, so like you can say this thing, when you are considering the single payment thing, then you use these two formulas, that is single payment compound amount factor and single payment present worth factor. In in the case in case where no annuity is involved. Okay. Then when you are required to calculate the future money from the principal money, Then how you will calculate it? That is 1 plus I to the power of n. And when you are expected to calculate the present money, you will reverse the future money factor. Okay. Next is regarding the equal payment factors. Okay. So we have four factors. These four factors: compound amount worth, present amount worth, sinking deposit fund, and capital recovery fund. Okay. So these four factors we have seen. So when you have the future money available with you, and when you have to determine the future money from the equal amount that are you are providing to the system, so then how you will calculate? That is 1 plus I to the power of n minus 1 divided by I. However, when you are required to calculate the sinking fund, when you are that is the annuity amount given the future value of the money, that is certain amount you already fix in your mind that this much amount should I get in the future, then it will be the inverse of the equal payment compound amount factor. Next is when you are expected to calculate the present value of the money from the annuity that you are providing in the future in the future. Then what is the present value of the money? Then how you will calculate that? You will calculate using equal payment present worth factor. That is 1 plus I to the power of n minus 1 divided by I into 1 plus I to the power of n. Okay. So final factor that is available to you is the equal payment capital recovery factor. How you will recover the factor? That means you have invested certain amount. That is, you have invested certain amount, and then uh, up to how much payment you should receive, so that you should recover your amount what you have provided to the uh, provided to you provided by you in the zeroth year. So that is equal payment capital recovery factor. That is inverse of equal payment present worth factor. Okay. So this helps you in making the economic decisions. So what are the criterias on which are based on which this economic decision making depends? That is the payback period. So what is payback period? So in payback period, you will don't consider the future value of the money. That means you don't consider the interest that should be incurred in future so as to regain the total value of the money. You only see the total amount that is there in the future and what you have spent in the in the present. That means suppose for an equipment, if you are spending 20,000 today, so that means if you are getting 2,000 every year, then up to how many years this fund will be recovered? So this fund will be recovered in 20 years. Okay, sorry, 10 years. So that is your payback period. When you are not considering the time value of the money, so only considering the amount into consideration, then it is your payback period. Another is return of investment, then discounted payback period, and net present value, NPV, then internal rate of return. Okay, then these two methods. So in this module, what we have covered the payback period, net present value method, and internal rate of return method. Okay, so we will see one all of them one by one. So in payback method, it is mentioned to you that is it is the period it is the period at which the investor gets the investment back. That means suppose you are investing 20,000 and you are getting 2,000 annually. So your payback period will be 20,000 divided by 2,000. That means 10 years. Okay. In this, you don't consider the time value of the money. Next is out of various alternatives, project with shorter payback is preferable. So suppose if you have seen the toll booths. So in toll booths that are generally operating nowadays on the PPP model, that is public-private partnership models. So in that, what NHAI is doing? So NHI is giving them the work, not giving any money, giving just an initial amount of investment, and then telling them that they will construct the money and they will construct the road based upon the specification provided to them. And then it is the responsibility of the contractor only to recover that money from the tolls that is provided to them at regular intervals. So the money that is recovered from the tolls up to a certain period, that is called as the payback period. Okay. So next is discounted payback period. So what is this the difference between the discounted payback period and the payback period? It is that it considers the time value of the money. So when you consider the time value of the money, you count it as the discounted payback period. Next, when you are considering the time value of the money is the net present value. So net present value is the sum of all the cash flows. It is the sum of the all cash flows discounted to present using the time value of the money. That means when you are considering all the cash flows based upon the time value of the money, that is the net present value. So net present value is earlier from the present value. So if we are from the present value to future value, if we are doing that, so how which factor we are using? We were using 1 plus I to the power of n. So from future value to present value, how we have done that? 1 plus I to the power of n. Okay. So this is what NPV is. So NPV tells you that what will be your present value of the money when your the future value of the money or the cash flows are given by CFTs. Okay. Next is internal rate of return. So what is internal rate of return? So that means when you so this is your return on percentage rate of return. So this is rate of return that you generally say, and what you say to this is so what you say to this is your discounted rate of return. So this is your discounted rate of return. Okay. So what is IRR? So internal rate of return is the discount rate. So please see, it is a discount rate at which the NPV of the cash flow is zero. That means you are expected to calculate this value of K. So when your NPV becomes equal to zero, that means your net present value will become equal to zero, then you call it as the internal rate of the return. So how you mathematically do that? So mathematically, IRR is calculated by making the NPV equation equal to zero. Okay, so for by this formula, you can see that CFT is the cash flow at an year T and is the life of the project. Okay, and we calculate it by using trial and error. Another thing we can use is the graphical method. So how you use graphical method? You plot the you plot NPVs. Yeah, this you plot NPVs for different discounted rate. That is 5%, 10%, 15%, 20%. Then you will reach a point. So the point at which your NPV is zero, that you will call it as internal rate of the return. Okay. So this is what we have covered in this current week, and also we have covered some portion of the calculation of the depreciation. So depreciation, how we will calculate? So depreciation is the decrease in the amount of the money from the present value of the money. So because of the use of the machine or the equipment during the particular project, so its value reduces year by year. So the decrease in the value of the equipment from the present from the purchase value, that we call it as a depreciation. So you calculate depreciation by many methods. So one is the straight line method, another is the some other squares, some certain name is there. I think some what is that? Sum of years method. Okay. So this is what you have covered in this week. So in most of the situation, what we have seen till now, in this alternatives have the equal life period. So whenever suppose we have taken the examples of the equipment, so in each time we have taken that when the equipment have the total life equal for both the cases, then what is the return of investment from that particular equipment. But in journal, in real time, each machine has different life period. They work differently under different conditions. So we have to take into account some. We have to be fair with the ranking process of the alternatives, so that lives should be modified such that they are equivalent. So how we will do? We will use two approaches. One is common multiple method, and one is study period method. So what we will do in common multiple method? So let's see. Let's say one machine has a total life period of 4 years, and another machine has a total life period of 3 years. Then how we will calculate its return? Then what we will do? We will take total 12 years into consideration. So in 12 years, three machines will be required by this. So from this, three machines will be required, and in this case, four machines will be required. So the rate of returns from both the cases we will see, and the one which is maximum, which is giving us the more money, we will take into consideration, and that is what common multiple method. So in this method, to evaluate the alternatives, the least common multiple of the life periods, that is least common multiples for 4 and 3 years, it is 12 years, is chosen as the coterminous life period. Okay. So in this case, you consider three machines. In this case, you consider four machines, and then you will calculate the return from these machines, and you will say that which machine is more beneficial for you. Another approach you can apply in this case is the study period method. So what you will do in study period method? In this method, a study period is chosen based upon the length of the project. Okay. So suppose 12 months of the project is there. Okay. So the shortest life period of the alternatives may be chosen as the study period. So in this case, if you have different estimated cost, or estimated time available to complete the project, so to estimate the return, you take the shortest period and then see whether the return is feasible to you or not. So this is what we have covered in this current week, that is week 3. So in this, you have seen that how you will calculate the time value of the money using different factors available with you based upon the single payment as well as the equal payment at regular intervals. And then you have seen how you will calculate the depreciation of the different equipments using the straight line methods and the sum of years method. And finally, two approaches based upon the common multiple method and the study period method. So let's solve few examples related to what we have seen in this current week. So what question one says to you? So what are the effective rate of interest? So you are expected to calculate the effective rate of the interest if the nominal rate of interest is 10%, which is compounding quarterly and monthly respectively. So that means you are expected to calculate the effective rate of interest. So calculate the effective rate of interest Just a second. So effective rate of interest is given by, as we seen in the first formula, wherein you are expected to calculate the present value, future value from the present value. How you will do that? So what you have done that 1 plus I to the power of n. Okay, so this is how you calculated the future value from the present value. So this is what is expected from you in this case. So in this case, you are expected to calculate effective rate of interest when your nominal rate of interest, that is your annual rate of interest, is 10%. Then what will be your compounding rate of interest quarterly and monthly? So your effective rate of interest becomes 1 plus I to the power of m raised to power n minus 1. Okay. So where m is number of months per year, number of months in an year taken into consideration. So so to you, interest is given to you as annual rate of interest. So now when you are expected to calculate the quarterly and the monthly rate of the interest, then how you will calculate? So when quarterly, that is at the rate quarterly, effective rate of interest will be equal to 1 plus I. So I here is 10%. It is zero point 0.1 divided by number of months, that is 4, and to the power of 4 minus 1. Okay, so let's calculate this. I think it is not 4, it is. So if you calculate this, what you will get? You will get it as 10.38%. Okay, so your 10%, which is your annual rate of interest, when compounded quarterly, it will become 10.38%. Next is when you will calculate it as monthly compounded interest. Okay, when considered monthly, so your effective rate of interest that will be equal to 1 plus zero point 0.1 divided by 12 to the power of 12 minus 1, and it comes out to be 10.47. So this is the power of compounding. As you can see, when you have taken the 10% rate of interest, which is compounded every year, when you make it as the quarterly rate of interest, then your effective rate of interest becomes 10.38%. Whereas when you make it as annual rate of interest, then it becomes 10.47%. That means 0.47% is your additional amount that you are getting, and for every monthly income. So that means 0.5% for if you have a large crore project, it will become the amount in certain amount of in thousands or in lakhs. Okay, so that is what you should be able to take into consideration. Another is question is, what is the equal payment compound amount factor? Okay, so equal payment compound amount factor. So what is the formula for that? So if you recall that, what is the formula for equal payment compound amount factor? It is this. Okay, so equal payment compound amount factor. That means when you are expected to calculate the future value given the annuity amount to you. Okay, then how you will calculate it? Okay, So your EPCAF is equal to 1 plus I to the power of n minus 1 divided by I. Okay, so put the values of I as well as the n. So what you will get here? So what you will get here is your factor comes out to be 6.1. That means if I go to that slide, I will show you. Yeah, this slide. That means if you are giving certain amount of money, that will increase. Suppose you are giving an A amount of money. You are giving A amount of money. So that amount of money after 5 years, after 5 years, taken I think 10% interest, it will become 6.1 A. Okay. So your amount which you are giving every month or every year will become 6 times to the amount you are spending. Okay. So this is what is equal payment compound amount factor is telling to you. So we will move to the next question. So next question tells you that the initial price of a certain construction equipment is 16 lakh. Okay. Then its salvage amount is 1 lakh. Salvage amount is the amount of the equipment after it becomes for no use, but without it is dismantled. So that is the final amount of money you will incur from that equipment when it is not purposely when it is not made for use into the project. That is the salvage amount. However, when you dismantle that equipment, that becomes the scrap value of that particular equipment. Okay, so salvage value given to you is 1 lakh, and your purchase amount is given to you is 16 lakh. Now you are expected to calculate the book value at the end of the 4 years using the linear depreciation method that is applied to the equipment. Okay, so your amount will become, so uh, purchase amount minus salvage amount is equal to 16 minus 1 lakhs, that is 15 lakh. And if it is given to you that it reaches the value of 1 lakh after 5 years. So your per year decrease in the amount, that is dt, will be equal to 15 lakhs divided by number of years, that is 5. So it comes out to be 3 lakhs per year. Now you are expected to calculate the book value. So book value will become, so after the at the end of 4 years, what it will become? It will become 16 minus this 3 lakhs per year into number of years into consideration, that is 4 years, that is 16 minus 12 lakhs, and what it is equal to 4 lakhs. Okay, so now if you calculate this depreciation based upon years of sum of years method, at the end of 3 years, then how you will calculate it? So for sum of years, your decrease in depreciation is equal to n minus t plus 1 divided by summation of I to the power of 1, sorry, I from 1 to n to I p minus s. However, in other words, how you will recall, let's see the simple thing. So that means after 1 year, your dt will be equal to, first is how many total number of years is there? 5. Then you divide it by sum of the years, that is 5 plus 4 plus 3 plus 2 plus 1. Okay, they, and multiply by p minus s, that is 15 lakhs. Okay, and this amount will become equal to 33.33%. Okay, after second year, your dt will be equal to 4 upon 5 plus 4 plus 3 plus 2 plus 1 of 15 lakhs. What that will become? It will become 26.67%. After 3 years, your dt will become 3 upon 5 plus 4 plus 3 plus 2 plus 1. Now, in this case, you don't have to remember the formula. Just decrease your total year by 1 in each year and then multiply it by certain amount. Then you will get the percentage decrease in the value. This comes out to be 20%. Okay. So, so your book value at the end of 3 years will be equal to, first is that becomes 1 lakh, which is the difference amount between the present principal value and the salvage value, plus, or I can say I will do it later. I will first calculate the depreciated amount. Okay. So your depreciated amount will be equal to, what is the percentages? Percentages are 33.3, 26.67 plus 20% of 15 lakh. This accumulates to 80% of 50 lakh, 15 lakh. That means 12 lakhs. Okay. This is the depreciated value. Now your book value will become purchase amount minus depreciated amount, and it will become 16 minus 12 lakhs, and this give you the answer of 4 lakhs. Okay, this is how you will solve the problem of sum of years method. Next question that is available to you, that is, if the sum of the years method as chosen to calculate the depreciation on the given equipment, what is the difference between the book values just after the second year and just after the fourth year. So for the third 3 years we have calculated. So now we'll calculate for the fourth year. So for the fourth year, your dt will be equal to 2 upon 5 plus 4 plus 3 plus 2 plus 1. Okay, that becomes, I think these are the percentages, so we should not take 5 upon, yeah, these are percentages, huh? So we should not take into account because otherwise I am not considering, I am taking the only the percentage case. I am taking the percentage depreciation amounts. So that percentage depreciation will be like this. Okay. So this percentage depreciations come out to be 13.33%. Okay. So now after second year, depreciated amount is will be equal to, if you remember, your first is 33.33% plus second is 26.67% of 15,000, 15 lakhs. So what it will become? So this amount will become 6 lakh. Okay. So your book value after 2 years will be 16 lakh minus 6 lakh. That will be 10 lakhs. Another is after the fourth year. So after fourth year, depreciated amount will be equal to 33% plus 26.67% plus 20% plus 13.33% of 15 lakhs. And if you calculate it, it will come out to, I think it is 93.33% of 15 lakhs. This is 33. This is 60% of 15 lakh. That is 9 lakhs. So this is your 9 lakhs. And 9 and 7 lakhs. Okay. In this case, it becomes around 14 lakh. So your book value after fourth year will be 16 minus 14 lakhs and that will be 2 lakhs. Okay. So the difference between book value after second and fourth year will be equal to first is 7 lakh minus 2 lakhs and it becomes 5 lakhs. Okay, this is how you are required to solve the problems related to sum of years method. So next you have a good problem. In this you are required to calculate the NPV of the project. So what it is mentioned in this question that the company X has invested an infrastructure project. Assume the initial one-time investment in the company to be 1 lakh, that is on year 0. And for every year, the projected annual cash flow of the project is given in table below. Now you are required to solve some problems, assuming the discounted rate as 10%, which is calculated annually, and you are required to calculate the net present value. Okay, so we have to solve this problem. So what is NPV? NPV is, if you can recall from previously, that is T is equal to 0 to N CFT divided by 1 plus I to the power of N, or I can say 1 to the I to the power of N. Okay, so now let's make a table. So for year, so we'll write it here year and the cash flows. I will make a table, then it will be easy for you to understand. Then discounted factor at the rate 10%. And then finally, you will be having the present value. So in 0th year, you will be having the outflow of the cash amount in 1 lakh rupees. In first year, it becomes 10,000. In second year, it becomes 20,000. Third year, 30,000. Fourth year, 40,000. Fifth year, 50,000. And for the sixth year, it is 40,000. Okay. Now you are required to calculate the discounted factor. So your discounted factor is this 1 upon this factor. Okay. So that means for the year 0, it will come out as 1 because anything power 0 is 1. Now your this factor for the first year will become 1 upon 1.1. That will become equal to 0.9524. Sorry, it becomes 0.9090. For the second year, it is 0.8264. Third year, it is 0.75131. For the fourth year, it is 0.683. Fifth year, it is 0.6709. And for the sixth year, it becomes 0.5644. Okay, if you calculate the amount by multiplying this factor, so your value will become this remains 1 lakh. Your 10,000 becomes 9090. This becomes 16,528. This becomes 22,539.3. This becomes 27,390. 320. You have to just multiply that row 1 and row 2. 31,045. And final, it becomes 22,576. Okay. Now you add all of these and you will get the total NPV. So your NPV in this case is coming out to be, I will write in next page. So NPV is sum of all present values that will be equal to, if you do that, it becomes 29,098.3. Okay, so your NPV is positive. That means this project is feasible for you. Okay, so now moving to the next case. In this, it is mentioned that you are expected to calculate the ratio of the NPV at a discounted annual rate of 5% and 15%. Now, what we have done in this for the 10% case, now we are expected to do for the 5% as well as for the 15% case. Okay, so let's do that. So again, we have to make a table. So first is year, then uh, cash flow, then discounted factor, at the rate 5%, and then we have discounted factor at the rate 15%. Then we will calculate their values. So the present value for 5% case, and finally present value for the 15% case. Okay, so we are doing for both the cases in one single table. I hope you will be able to understand that. Okay, so let's write 0, 1, 2, 3, 4, 5, and 6. Okay, so what is the cash flow that is happening? So in this case, it is 1 lakh. I directly write it as minus 100K. Okay, then we have 10K, 20K, 30K, 40K, 50K, and then again 40K. So in this case, what will the discounted factor will become? So your discounted factor will become for 5%, that will be, here it is 1. For 0, it is always 1. Then you will be having for 5%, it is 0.9524. I am directly giving you the values. You can confirm it later. 0.9070, 0.8638, 0.8227, 0.7835, and then 0.7462. For the 15%, it becomes 0.8696, 0.7561, 0.6575, then 0.5718, then 0.4972, then 0.4323. So multiply row, this row, that is cash flow row, and the discounted factor at the rate 5% row. What you will get? You will get different values. So what you will get? So here you will get minus 1 lakh. Lakh, I think it is important. Then you will be having 9524, 18140, 25914, 32928, 39175, 29848. Okay. For the 15% case, how it will become? It will become minus 1 lakh, 8696 15122 19725 22 872 24860 and 17292. So now how you will calculate the NPV? So NPV for 5% case, if you amount all the values, you will reach the total value as 55,529 rupees. However, for 15% case, for 15% discounted rate, your value will become 8567. So your ratio, that is ratio of NPV at the rate 5% to the ratio of NPV of 15%, what it will become? It will become 55,529 divided by 8,067. It will become equal to 6.482. Okay, this is how you will calculate. So that means as your discounted rate increases, your net present value decreases. However, when the discounted rate increases or decreases, then your net present value will increase. Now, last question of our today is you have to calculate the internal rate of return. So we have given you the some. So what is internal rate of return? When your NPV becomes equal to zero, then you the formula for NPV, that is sum of t to the power of 0 CFT cash flow divided by 1 plus I to the power of n will become equal to 0. Now this I will become your IRR in this case. So how you will be calculating this here, because there is a summation. First thing is, first thing you can do is you can make hit and trials and for calculate for each and every case, that is 5%, 15%, 20%, and whenever and the group in which it is coming out to be negative, then you will change the value and do hit and trial method, that is trial and error method. Another thing that you can do in this case, that is you plot a graph, directly plot a graph. Like in this case we have plotted, so for 5% we got the value as 55,512. For 10% we got 29,000, that is it is decreasing with increasing the rate of return. And for 15% we got it 0.8566, and for 20 it is further reduced, and for 25 it is further reduced. So from 15 to 20 you got a range in which your NPV is zero. So this is the point where your NPV is zero, and the point where NPV is zero, that you call it as IRR. So in this case your IRR is 17.5%. Okay, so this is what we have covered in this current week. If anyone has any doubt, they can may ask right now. I'm waiting for them.
हेलो सर।
Yes.
सर जो सैल्वेज वैल्यू होता है
Sorry.
वो एक बार सैल्वेज वैल्यू जो होता है
जी,
उसको एक बार और एक्सप्लेन कर दीजिए सर, उसको हम लोग कैसे यूज करते हैं।
सैल्वेज वैल्यू आप पे डिपेंड, सैल्वेज वैल्यू जो होता है आप पे ऑलरेडी डिफाइंड होता है. सैल्वेज वैल्यू क्या होता है? एक आपने इक्विपमेंट लिया, एक सर्टेन टाइम बाद जो होता है आप उसको यूज नहीं कर पाते किसी भी पर्टिकुलर प्रोजेक्ट में. सो उस टाइम पे जो उसकी कॉस्ट होती है वो उसकी सैल्वेज वैल्यू होती है. बट अगर सपोज आपने आपके पास मशीन पड़ी है, ठीक है, अभी उसकी वैल्यू है, बट अगर आपने उसको तोड़ फोड़ दिया, मतलब उसके सारे पार्ट्स अलग कर दिए, तब वो आपके लिए स्क्रैप है. तो जो वैल्यू बिना किसी ऑब्जेक्ट को डिसमेंटल किए आप रख सकते हो, वो आपकी उसकी सैल्वेज वैल्यू है। जब आप उसको डिसमेंटल कर देते हो तब वो आप उसकी आपकी वो स्क्रैप वैल्यू बन जाती है। जैसे आपकी कार है, आपने आज कार परचेज की, 20 साल बाद आपकी उस कार की लाइफ, आपकी वो कार यूजेबल नहीं है, मतलब आप उसको चलाने की कोशिश कर रहे हो, वो हर 10 दिन बाद आपको प्रॉब्लम दे रही है, तो आप चाहते हो कि भाई इसकी लाइफ पूरी हो चुकी है, अब ये मेरी किसी काम की नहीं है। तो आप किसी गैरेज में जाते हो, आप उसको बोलते हो कि मैं इसको बेचना चाहता हूँ, तो वो जिस अमाउंट पे आपसे खरीदेगा वो आपकी सैल्वेज वैल्यू हो गई। दूसरा तरीका है आपके पास बेचने का, उसको आप उसके हर पार्ट बेचो, आप उसके टायर बेचो, आप उसका इंजन बेचो, आप उसका स्टेयरिंग व्हील बेचो, आप उसके बोनेट बेचो, आप उसके डोर्स बेचो। सो उसको तोड़ के जो आप अमाउंट एक्यूमुलेट करोगे वो आपकी स्क्रैप वैल्यू हो जाएगी। सो ये डिफरेंस है सैल्वेज वैल्यू और स्क्रैप वैल्यू में।
यस सर। और सर एक और डाउट था,
हम्म।
ये जितने मेथड्स हम लोग पढ़े हैं अभी, पहले जो इक्वल वाला हो गया और एक सिंगल वाला हो गया, तो उनको
हाँ,
कहाँ पे और कैसे यूज करना है, ये कैसे पता चलेगा?
वो आपके प्रोजेक्ट प्रोजेक्ट डिपेंड करता है। ठीक है, सपोज मोस्टली आपको डिस्काउंटेड रेट ऑफ रिटर्न जब निकालना होगा तब आपको सिंगल अमाउंट दिया होगा। जब भी आपको सपोज दिया होगा कि आप पर्टिकुलर अमाउंट हर मंथली या हर ईयरली दे रहे हो, तब आपको इक्वल अमाउंट वाला मेथड यूज करना है। जब आपका लमसम अमाउंट यूज हो रहा है, दैट इज आज आज आपका वैल्यू 10 लाख रुपए है, आज से 20 साल बाद इसका वैल्यू 50 लाख है, तब आप सिंगल पेमेंट वाला मेथड यूज करोगे। और अगर दूसरा ऑल्टरनेटिव देखा जाए, आप तो फ्यूचर वैल्यू निकालना और आप बोल रहे हो मैं हर महीने 5-5 हज़ार रुपए दूंगा तो मेरी फ्यूचर वैल्यू क्या होगी, तब आपने इक्वल इक्वल इन्वेस्टमेंट वाला मेथड यूज करना है।
यस सर। सर क्वेश्चन नंबर 1 एक बार और एक्सप्लेन कर दीजिए ना सर, नॉमिनल रेट ऑफ इंटरेस्ट।
सो इसमें क्या होता है, लाइकवाइज हाँ, इसमें क्या होता है, आपको इफेक्टिव रेट ऑफ इंटरेस्ट कैलकुलेट करना है। सो हमेशा क्या होता है जो आपको, सो आई विल टॉक इन इंग्लिश, व्हाट हैपेंस दैट मोस्टली दिस इंटरेस्ट इज गिवन टू यू एनुअली, सो दिस इंटरेस्ट इज योर एनुअल इंटरेस्ट। However, in certain case, what happens, your interest get accumulated in quarterly or monthly. So when the your interest becomes accumulated quarterly or monthly, so what will you do? You divide it by the number of the month that is given to you. So here your number of the month is 4. So in for each quarter, so for the quarter, so that is coming out to be 4 months. Yeah, I think here it should be 3. क्योंकि क्वार्टर पूछा है ना आपको, तो क्वार्टर 3 महीने का होता है। तो अगर मैं इसको तीन के साथ करूँ, यहाँ 4 नहीं आना चाहिए था, यहाँ 3 आना चाहिए था। सो इफ इट इज 3, देन योर वैल्यू विल बी 0.1/3, देन इट इज 10.34%। 10.34%। तो जब भी आपको उसमें बोला होगा कि इफेक्टिव रेट ऑफ इंटरेस्ट निकालना है, मोस्टली होता क्या है, आपका जो इंटरेस्ट जो होता है क्यूमुलेट होता है, वो ईयरली ईयरली बेसिस पे होता है, एनुअली बेसिस पे। बट समटाइम्स इन सर्टेन केसेस अदर प्रोजेक्ट में आपको दिया हो कि आपका जो क्यूमुलेशन होगा इन अमाउंट का, वो क्वार्टरली होगा या मंथली होगा, तब आपका जो एनुअल रेट ऑफ इंटरेस्ट होगा वो बढ़ जाएगा। क्योंकि आप सपोज आपने जो एक आज 100 रुपए दिए, अगर आप उसका ईयरली अमाउंट देखोगे 10% के हिसाब से, तो वो हो जाएगा 110 रुपए। हाउएवर अगर आपको 10% इंटरेस्ट ही 100 रुपए में मिल रहा है, सो दैट मीन्स आपको मंथली में 10.47% का इंटरेस्ट मिल रहा है। ओके, ये मतलब होता है आपका मंथली एक्यूमुलेशन का और क्वार्टरली एक्यूमुलेशन का। एनीवन
मंथली है
एल्स?
तो मंथली है तो उसमें हम 1 मंथ रखेंगे ना, जैसे मंथली मंथली
हाँ,
करते हैं।
तो साल में 12 महीने होते हैं ना, तो जो इंटरेस्ट गिवन है आपको वो एनुअली है। तो आप उसको 12 महीने से डिवाइड करोगे तो आपको मंथली इंटरेस्ट हो जाए।
यस सर।
ठीक है।
ठीक है सर, थैंक यू।
Who is talking? Anyone else have any doubt? Or if you don't have any doubt, we will wrap up this session. Okay. I'll wait for 1 minute for you to respond in any question. No, not only in question, in concept, or in any whatever we have covered till now. If you have any doubt, you can ask right now. So in this week, what we have covered some uh, basic concepts regarding the time value of money. So how the with time the value of money changes. That is what we have covered in this week, and also covered some concepts related to the depreciation. So this is what accounts for the economics of the construction project. So this module is basically focusing on how the economics of the project changes with the time and what factors are required to be taken into consideration so as to estimate whether the project is feasible to you. So how you will do that? You will calculate the net present value, or you calculate the internal rate of return. By that, you will came to know that whether this project in future is feasible to you or not. So this is what we have covered in this current week. So if anyone has any doubt, they can also post on the discussion forum that is provided to you by in Swayam app, and where we will try to resolve your queries as soon as possible. So in this week, we have covered up to the estimation or the time value of the money concepts or the economics of this project, of the construction project. Next week, we will see another module, and we will see try to solve the problems related to that current week. Till now, we will wrap up this session. So thank you everyone. Have a nice day. Enjoy your weekend.